Have you ever been right in the middle of something important when your computer suddenly freezes, crashes, and goes completely black? In a traditional data center, every server is a single fault domain. This means if that one physical box breaks, every application running inside of it fails at the exact same moment. Google Compute Engine solves this physical bottleneck by letting you ditch the metal box entirely. Instead, you rent a virtual computer. This creates a clear division of labor. Google handles the heavy lifting, the power, the cooling, and the physical repairs, while you operate a clean, isolated virtual workspace layered on top. By separating your software from the physical hardware, you're no longer at the mercy of a single broken circuit board or a failing power supply. Because these computers are virtual, they don't have to come in standard factory shapes. You can size them to fit whatever specific task you're working on. Google takes massive physical servers and smoothly slices them into distinct virtual instances called machine families. For example, the general-purpose slice is your balanced everyday worker. It's the go-to choice for web servers and standard business applications. If your application needs massive data in active memory, you choose a memory-optimized slice instead. And for intense mathematical tasks or high-performance simulations, grab a compute-optimized slice, which focuses entirely on raw processing speed. On Compute Engine, you're no longer stuck with a generic computer. You simply rent the exact ratio of processing power and memory that your application requires. Even with virtual machines, the physical hardware underneath eventually needs a software patch or a hardware repair. So what happens to your work when that day comes? When a physical server goes offline, Google uses live migration. Your running virtual machine smoothly glides from the old server to a new physical host. This happens in real time with zero downtime. Your application never stops and never loses its state. It's a powerful safety net, but it does have specific architectural limits. Virtual machines using specialized graphics chips or those running on heavily discounted temporary capacity cannot be migrated. In those cases, the machine faces a hard shutdown instead of a move. While live migration makes your standard infrastructure feel near invincible, you'll need to build extra safety nets when using that specialized hardware. One of the biggest advantages of the cloud is its financial flexibility. You only pay for the virtual resources you're actually using at any given moment. Google applies sustained use discounts automatically. Running a machine for most of the month lowers your rate. Committing for a full year provides steeper savings. Finally, spa VMs use spare capacity at massive discounts, ideal for flexible, interruptible jobs. The trade-off is that Google can reclaim that capacity at any time. If they do, they'll send a 30-second warning signal before the machine shuts down. Mastering these different tiers ensures you don't waste your budget, allowing you to pay a premium only when uninterrupted reliability is your top priority. Managing individual virtual machines one by one is an inefficient way to run a business. It's slow and it leaves too much room for human error. To solve this, use managed instance groups. It clusters machines into a unified fleet following a blueprint. This fleet is self-healing. If a machine crashes, it instantly builds a replacement. When traffic spikes, it scales out automatically, adding machines. Even software updates are automated. The group replaces old machines with new ones sequentially, ensuring your application stays online for every single customer during the transition. Compute Engine provides the framework for an automated, resilient infrastructure that fixes itself, scales on demand, and optimizes its own costs.